Hello, this video is for textbook chapter 2, lesson 1. It is titled Properties and Operations, where our objective is to use properties of addition and multiplication. Our vocabulary for this lesson is additive identity and multiplicative identity. So in English, commute means to change locations. If someone says, I have to commute to work, that means they're going from their house to where they work. If you think of a commuter train, it's a train that gets you from point A to point B. Commute means to change locations. And associate means to group together. You might say, who do you associate with? Who are your friends? Who are the people that you hang out with? All right. So, or you might say, what words do you, what things do you associate with the feeling of, feeling happy? And you start to come up with a group of things that make you happy, because it's associate means to group things together. So these words have similar meanings in mathematics. Commutative, notice the root word commute. Commutative properties let you change the position of numbers in a sum or product. Sum is when we add, and a product is when we multiply. And as you see in our objective, we're dealing with properties of addition and multiplication. So commutative properties let you change the locations or change the order of the numbers. Associative properties let you group numbers in a sum or product together. So notice that the word associate is the root word in associative, and the associative properties are what let you group numbers in a sum or product. And again, sum means to add and product means to multiply. So here's a table with the commutative and associative properties of addition and also multiplication. And you'll find that we don't have commutative property of subtraction or commutative property of division, because whenever it comes right down to it, we really only have two operations, and that is that of addition and multiplication. You might say, well, what about subtraction? Well, actually, subtraction is just the inverse property of addition. For instance, this 4 plus negative 7, we could call that 4 minus 7, right? We're going to get the same answer. So subtraction is just the inverse property of addition. And likewise, whenever we talk about division, it's actually the inverse operation of multiplication. And later on, whenever we start solving linear equations, especially linear equations, we're going to undo addition and subtraction with addition or subtraction, and we're going to undo multiplication with division and division with multiplication. And this works because they are inverse operations of each other. Inverse operation of addition is subtraction, and the inverse operation of multiplication is, well, division. So that's why you're not going to see such and such property of subtraction or such and such property of division. We're only going to be dealing with properties of addition and properties of multiplication. So in the table here, first is the commutative property of addition, and next to it, the commutative property of multiplication. So in words, we say in a sum, when you add, you can add the numbers in any order, such as 4 plus negative 7 is equal to negative 7 plus 4. Notice that commute means to change locations. We just switched the numbers around. The 4 moved to the second position, and the 7 moved to the first position. If we do this in algebra, we say that A plus B is equal to B plus A. Still the same thing. They're equal to one another because it's addition. They can change location. Change in location is all about commuting. Therefore, it's the commutative property of addition. Now we can do the same with multiplication as well. We have commutative property of multiplication. In words, we say in a product, product's what you get when you multiply, you can multiply the numbers in any order. Example using actual numbers is 8 times negative 5. Well, that's equal to negative 5 times 8. Notice that we had the 8 first and the negative 5 second. Now we just switch their order, change position. They commuted, move from one location to the other. Now we have negative 5 times 8. In algebra, we would say this as A times B is equal to B times A. We can reverse the order. We can move them around because multiplication has the commutative property. Next is associative property of addition and associative property of multiplication. In words, we say changing the grouping, because grouping is what associative property is all about. Changing the grouping of the numbers in a sum does not change the sum. So we could group the 9 and the 6 together to get, what, 15, then add 2 and get 17. And that would be the same as, notice the order didn't change, 9, 6, 2, 9, 6, 2. It's just we had the 9 grouped with the 6, did that addition, then we added the 2. Or we could group the 6 with the 2 and get 8 and add that to 9. And indeed, we get 17. Did I say 17 on the first one? 9 plus 6 is 15 plus 2 more, indeed 17. So we could say this in algebra as the quantity, these parentheses we read as the quantity of A plus B plus C is equal to A plus the quantity of B plus C. We just regrouped, took the parentheses, instead of having A grouped with B, then we had B grouped with C instead. Order's the same, it's just the grouping's different. For associative property multiplication, it's the same thing. Changing the grouping of the numbers in a product means to multiply, does not change the product. Get the same answer. 3 times 10 is 30. Times 4 is what? 120. Over here, notice the order's the same. We have 3, 10, 4, 3, 10, 4. We didn't change the order any. We just regrouped. I think we got 120 over here, didn't we? Let's see. 10 times 4 is 40. 40 times 3, 120. Sure enough, they're equal to one another. In algebra, we could say this as the product of A times B, then multiply that times C, is the same as the product of B times C, then multiplied by the factor of A. So there it is, the commutative property. Commutative means to change position because commute is the root word. And then associative property. Associative property is who you associate with, or what we're associating each thing with. And it's all about grouping. In mathematics, we show grouping using parentheses. So if the order changes, chances are commutative property. If the order stays the same but the parentheses are being used and regroupings being done, then it is the associative property. So let's see, how can these properties actually help us? Well, example 1, it's going to show us using some mental math how associative property and commutative property helps us do mental math. Using as properties of addition, you buy a portable CD player for $48. Now, I don't know if they sell CD players anymore. Everybody's doing like MP3s. And we all have Amazon Music and Siri to play our music for us. But nonetheless, you buy a portable CD player for $48, rechargeable batteries with the charger for $25, and a CD case for $12. Find the total cost. So we have 48 plus 25 plus 12. We see that here, 48 plus 25 plus 12. Now, order of operation says that we have to first add the 48 plus the 25. But let's go ahead and use some order operations to do some mental math, because as I look at this over here, I'm thinking that 48 goes with that 12 really nice. And if I added those together, then added the 25, would probably help quite a bit. So I'm going to use the commutative property. Notice that the 48 and the 25 are still grouped together in the same parentheses. However, we've just changed places. So they change places, so it's commutative property. Now we're going to regroup the 48 with the 12 here and leave the 25 out over here. So no longer is 48 associated with 25. Now 48 is associated with 12. Notice the order didn't change. 25, 48, 12, 25, 48, 12. This is the associative property. So from this line to this line, we use the associative property. Now we add 48 plus 12. Well, that's easy. That's 60, right? And it doesn't say so here, but this is actually called the closure property. The closure property says that whenever we take two numbers from a set and interact them together through whatever the operation is, the result is a number that belongs to that same set. So for instance, 48 and 12, they're both whole numbers. 60 is a whole number. So this is actually what I would refer to this as the closure property. So we have 48 plus 12 through closure property. That is adding 48 and 12, we would get 60. Now 60 plus 25 is a lot easier because in our mind we're thinking of 25 as 20 plus 5, right? And 60 plus 20 is 80 plus 5 more is indeed 85. So if you were looking at this and you were thinking about this problem up here, you think, oh, I need to take the 12 and the 48 to make 60, add 25, and that would give me 85. Well, what you're doing in your mind is all this right here. You're incorporating this commutative and associative properties of addition in order to do the mental math for that to find out that the total cost is indeed $85. Next one here. Using properties of multiplication. So we use properties of addition in example 1. Now we use properties of multiplication here in example 2. We have the task of evaluating 4xy when x is -7 and when y is 25. We know that evaluate means we plug in those values for those variables and actually solve it to some answer here. So if we substitute in those values, we end up with 4 times -7, because that's what x is. And we have 25 here, because y equals 25. So we end up with 4 times -7 times 25. Now you're probably thinking, and hopefully you're thinking, that, gee, 25 times 4 is easy. That's like 100, right? And then I just need to take 100 and multiply it times -700. And, well, 100 times 7, 700. Positive times negative is negative. So yeah, the answer is -700. And if you're doing that in your mind, what you're doing is you're doing all these I saw order operations here. You're doing all of these properties of multiplication. Most likely the first one that you did is that after substituting this in, you realize order operation says, oh, I have to multiply these two together first. But, so order operation says multiply 7 times the 4 by the -7. But let's go ahead and use commutative property and switch them around. -7 times 4. That's commutative property. They changed position, right? Move from one place to the other to commutative property. Now we're going to regroup the 4 with the 25 right here on this line, and that is associative property. The numbers stay in the same order, -7, 4, 25, -7, 4, 25. All we did was we regrouped the 4 with the 25 instead of having it grouped with the -7. Because 4 times 25, yeah, buddy, we can do that in our head. That's 100. And that is the closure property, or multiplying 4 by 25 to get 100. Now we can simply do this, -7 times 100 to get -700. Now there is another way you could have done it. You could also evaluate the expression 4 times -7 times 25 in this example here simply by multiplying from left to right. 4 times -7 is -28. Now that's probably not mentally too difficult. 4 times 7 is 28. Positive times negative is negative. That part's not all that bad. But really, mental mathing 28 times 25? That's probably not something that most people would do in their head. You probably get a calculator or get a piece of paper out and scratch it out and use a traditional algorithm to solve that. And whenever I say traditional algorithm, you would have done, 28 times 25, and then you would have done all that. 8 times 5 is 40. And see, I can't help myself. I'm actually going to work it out. 16, 1, 4, 5. 0, 0, carry the 1, 6, and I missed one someplace, and not sure where that was. 10, carry the 1, 5 times 2 is 10. Not sure where I missed it, but someplace I missed out on one, which is a good illustration of why you would realize that, 4 times 25 is 100, and then let's multiply it times -7. If you did that mentally, then you are incorporating all of these properties of multiplication to do that mentally. All right, let's go ahead and look at what they have down here in the checkpoint stuff. And looking at the first one here, you should realize, hopefully you're realizing, that, wow, the 17 and the 13 would go together really nice, right? Because what's that going to be, 30? So what we're doing is, let's rewrite 17. This reminds me of my days in college where we had to write these long things and we had to explain every single line that we did, that we changed, just like they're doing here in this. So I can regroup the, let's go ahead and change the order. This would be 36 plus 17 and plus 13, and we just switched them, so this is the commutative property. Now let's regroup 36 plus, and let's regroup the 17 with the 13, and this is called the associative property, right? Because we reassociated it. Now we got 36 plus, and 17 plus 3 is 30. To me, I would call this closure property. And then we would then take 36 plus 30 for 66, and again, that would be the closure property as well, right? What the textbook is calling add, right? On both lines, we added. So in this case, 1 would be 66. Now, if I took number 2, and we'll do number 2 up over here to the right, we have 8 times negative 3. Remember, no operation signs in between these. Here and here means that it is multiplying. So remember that we're multiplying. Now, I'm probably thinking that 8 times 5 is 40, and that's going to make it a lot easier. I'd rather do 40 times negative 3 than to do negative 24 times 5. So what I would do is I would first, order operation says that I need to take 8 and multiply that times negative 3, right? And then multiply that times 5. But I'm going to go ahead and switch their position. This is order of operations. Never realized that before. And so never abbreviated order of operations before. So I want to then switch their places. So I'm going to do negative 3 and flip it around with the 8, right? And so they change position. So this is the commutative property because they moved from one location to the other. They commuted. Now I'm going to reassociate the 8 with the 5. That's times. I'm going to go ahead and put that in there. So this I reassociated. So this is the association property. And now I have negative 3 times 8 times 5 is 40. This was to multiply, right? I would call that closure if I were still in that college class. And then now I need to multiply again, and negative times positive is negative, and 3 times 40 is 120. So negative 120. And I could do the same with this. On this one here, notice that the 0.4 and the 0.6 are going to go together really well. That would be 7, and the 0.4 would make that 8, and 3 more would be 11, right? If we put these two together. And then we're going to add that 11 to the 9.7, which we would end up with 7 and 20.7, and make it a lot easier that way. Okay, so let's go ahead and look at using properties to simplify variable expressions. So simplifying variable expressions, on this one here, simplifying is different than evaluating. We take an expression, and it may not be as simple as possible. There might be a simpler way of writing it without it being, well, say so long, right? And I don't mean so long as in goodbye, but I mean as in its length, right? So on this one here, notice that we have the order operations that says, well, I guess I'll go and keep underline. Order operation says, okay, first we have to add these together, right? Because it's all addition, so we do addition from left to right. So order operation says, oh, you have to do the x plus the 3. But we could reassociate it and regroup the 3 with the 6. And then we could do the 3 plus 6 to get the 9 here and end up with x plus 9. We call it simplifying because notice that this and these two are actually equal to one another. If x were 4, right? Let's say x were 4. We'd have 4 plus 6 is 10, and this would be 13. And if x was 4, we would still have 13. So we haven't changed the value of it. We've just simplified it a bit. It's now in simpler form, thus simplify. So that is the difference between evaluating and simplifying. Here we have 4 times 8y. Well, order of operations says that we have to do what's in parentheses first, so we have to do the 8 times the y, but we don't know what y is yet. But we could reassociate, notice 4, 8y, the order for 8y. For 8y, we've not changed the order, but we have reassociated the 8 with the 4 instead of with the y. Now we can do 8 times 4, that's 32, and we still need to bring down that y. We still have to multiply that y. We can't get an actual answer yet because we don't know the value of y, but we can simplify this 4 times the quantity of 8 times y and simplify that to 32y. In our checkbook, wish I had a checkbook. In our checkpoint here, we are asked to simplify these. So on this one here, we have m plus 5 plus 9. Order operation says, oh, you have to add these two first. But let's go ahead and reassociate using the associative property of addition. We can reassociate that 5 with the 9. Now we can do m plus, and 5 plus 9 is 14. Now, if you wanted to, you could actually use the commutative property again and call that 14 plus m. That would work as well also. Oh, let's do number 8. It is a multiplication one. That looks good. So we have 2 times r, or 2r, times negative 5. Now we could take that r and disassociate it from the 2 and reassociate it with the r, and this is multiplying here. I'm going to use parentheses. Got to be careful. Almost put r minus 5, which is not the case. So I would reassociate the r with the minus 5. Now I could then, this is associative property. Then through the commutative property, I could then move the negative 5 to the left, the r here. And now that I've done that, I could actually write this. It'd be a little bit neater to make that negative 5r. And that is the commutative property. So they change position, right? Now I could regroup the 2 with the negative 5. Use parentheses to hold that in there. And the r would be out here by itself. And since I regrouped, it didn't change the order. This is the associative property. Now I can do the 2 times negative 5 to get negative 10, and then bring down the r, and I could then say that this is simplified to negative 10r. Now you wouldn't have to do all that. You'd realize, oh, negative 5 times 2 is negative 10, and I still have the variable of r that needs to be multiplied. Okay, so we better move along. This video is getting kind of lengthy. I kind of like to keep them not too terribly long, but this one's really getting up there. So let's jump over to the identity properties. When 0 is added to any number, or when any number is multiplied by 1, the result is identical to the original number. These properties of 0 and 1 are called identity properties, and the numbers 0 and 1 are called the identities, or I like to call them the identity element. It's the element, it's the number that's within a set of numbers. It's that one that gives it its identity, or creates that identity property for us, you might say. So this applies to addition and multiplication. Again, we don't have identity properties of subtraction and identity properties of division, but we do of addition and multiplication. So in words, we say that the sum, that is to add, the sum of a number and the identity, the additive identity, which is 0, is the number. That is to say that negative 6 plus 0 is negative 6. So a plus 0 is a. Identity. If you look at your ID, whenever you're old enough, you'll have a driver's license. When you look at it, whose picture's on it? You. Whenever you look at your license, you see yourself. It's your ID. It's your identification. And so anytime that through addition a number looks into the mirror of 0, it sees itself. Just like you look into a mirror, you see a reflection of yourself. Also, with the identity property of multiplications, the product, that is to multiply, the product of a number and the multiplicative identity, which is 1, is that number. So 4 times 1 is 4. Anything times 1 is equal to itself. In algebra, we say a times 1. Any number a times the value of 1 is going to equal a. So the identity property, or the identity element of multiplication, is 1. A looks into the multiplication mirror of 1 and sees itself. So if we have a plus 0 equals a, so the identity element of addition is 0, and a times 1 equals a, so the identity element of multiplication is 1. So in example 4, identifying properties, here we have the identity element of multiplication, because negative 5 is being multiplied times 1, and we get negative 5. Anything times 1 is equal to itself. That is the identity property of multiplication. Here we have 2, negative 9, negative 9, 2. The order changed, right? They moved. So this is the commutative property of addition. Here we have y squared plus 0 equals y squared. Well, notice 0 is the identity element of addition, so this is the identity property of addition. Anything plus 0 is equal to itself. And then finally, let's look. We have 2pq, 2pq. The order is the same, so it's not commutative property, but the parentheses have changed. P is no longer associated with Q. Now P is associated with 2. So this is the associative property of multiplication. All right, the next thing we're going to look at, yes, there's a lot in this lesson, there really is. So we've covered commutative property of addition and multiplication. We covered the associative property of addition and multiplication. We covered the identity property of addition and multiplication. Now we're going to talk about unit analysis. You can use unit analysis to find a conversion factor that converts a given measurement to different units. A conversion factor such as 1 foot is to 12 inches, 1 foot over 12 inches, it's equal to 1. So you kind of see why this is coming up in this lesson, because all conversion factors have a value of 1, and we just got done talking about how 1 is the identity element of multiplication, so that probably makes sense why we're seeing it in this lesson. So 1 foot over 12 inches is equal to 12 inches over 12 inches. Any number over itself is equal to 1. 12 inches over 12 inches is equal to 1. If the numerator and the denominator are the same, that fraction will always have a value of 1. So the identity property of multiplication tells you that multiplying a measurement by a conversion factor does not change the measurement. Well, this works really well whenever we're trying to, convert units, right? That's why we call it a conversion factor. Here down in review help, I think many of us know that there are 12 inches in a foot. However, in order to create this conversion factor, you would indeed have to know that that 1 foot is equal to 12 inches. There may be other measurements, like maybe ounces to pounds, or tons to pounds. Switching from pounds to tons, you'd have to know that there are 2,000 pounds in 1 ton. So you might have to look for tables, or you could always Google and see what's what. So looking at example 5, multiplying a conversion factor. So here we have roller coasters. The Steel Dragon 2000 is the world's longest roller coaster. Its length is 2,711 yards. How long is the roller coaster in feet? Well, our solution is that first we're going to need a conversion factor, because they told us how long it is in yards, but we need to know how long is it in feet. So we need to find a conversion factor that converts yards to feet. The statement 1 yard equals 3 feet gives you 2 conversion factors. We could either have factor 1 that says 1 yard is equal to 3 feet, or we have factor 2 which says 3 feet is equal to 1 yard. They're both correct, and also they both have a value of 1, so they are conversion factors, because, well, 1 yard is 3 feet, so 3 feet over 3 feet would be 1, or 3 feet over 3 feet would be 1. That's correct. Any number over itself is equal to 1, even if the measurements are the same. So unit analysis shows that a conversion factor that converts yards to feet has feet in the numerator and yards in the denominator, such as this situation here. We want yards to cancel yards because we need feet to be the answer. So we are going to cancel out what's in the denominator, and we need what's left in the numerator. So the question is asking us for feet, so we want this one here because feet is in the numerator because the yards are going to cancel out like you see here. So we multiply the roller coaster's length by factor 2, this one right here from step 1. So we have 2,711 yards is equal to, now we're just applying that conversion factor, right? Remember, a conversion factor has a value of 1, so we're not changing this by rewriting 2,711 yards is equal to 2,711 yards times this conversion factor, because the conversion factor has a value of 1. Yards is going to cancel yards. And then we're going to do 2,711 times 3 is going to give us 8,133. And then feet is the label we have left over because yards canceled yards, and that gives us feet. So the answer is that the roller coaster is 8,133 feet long. Now, many people probably would have realized that, oh, there's 3 feet in a yard, so let's just multiply this number by 3, which is what happens here. So the conversion factor kind of helps explain why we multiply it by 3. So that brings us to our guided practice. Which property allows you to write 4 plus the quantity of 3 plus 9 as the quantity of 4 plus 3 plus 9? Well, 439, 439. Order is the same, but we've reassociated the 3 with the 4 here whenever it was associated with the 9. So this would be the associative property, and of addition or multiplication, it is of addition. Explain how the commutative and associative properties of multiplication can help you to evaluate the product of 5 times 17 times 2. Well, 5 times 17 and then multiply that by 2 would not work very well. However, we could, through some regrouping of associative property and then changing the order, we could end up with the 17 over here and the 5 over here and the 2 here. Then we could group these together to get 17 times 10. And then, real easy, like we'd realize, oh, that's 170. Some mental math here. This is pretty much what we had. Let's just do one of them. So we could take the -4 and the -5, and through some associative property and commutative properties, we could go ahead and multiply those together, and we'd have the 9. And then we need to multiply that times the product of -4 and -5. Negative times negative is positive, so this is going to be a positive 20. And then 9 times 2 is 18, and throw that 0 on the end, we would have 180. Evaluate means to actually plug in the values and get an answer. So this would be 33 times x is 5, and y is -2. So we could multiply the 5 and -2, 33 times. Positive times negative is negative. 5 times 2 is 10. And positive times negative is negative, and 33 times 10 is 330, multiplying 33 by the 1 and then throwing the 0 on the end. Simplify means to just make it a little bit simpler. Let's look at number 11. We can't actually evaluate it, but we can simplify it. On this one here, order operation says, oh, we'd have to do this first, -2 plus y. But what if we took that and changed the order of y plus -2, right? Change the order, and plus 8. And this would be, we just change position, so this is the commutative property. And then we could take y plus, and then we could associate the -2 with the 8 instead, do the associative property. And then we'd have y plus -2 plus 8 is going to be, what, a positive 6. And this would be simplified, y plus 6. All right. despite the fact that I am well over 30 minutes on this video, I'll go ahead and we'll look at the error analysis. They have 80 ounces equals 80 ounces, 16 ounces to a pound, and they get 1280. That must be 80 times 16 is 1280, but this is wrong. Why is it? Well, they've used the wrong conversion factor here. Notice that ounces needed to cancel out ounces. We needed ounces down here at the bottom. If we would have done that, we would have ended up with, in this case here, we would have gone the other way. This would not have been 16 ounces to 1 pound. This would have been 1 pound, LBS for pound, over 16 ounces. And then we would have had 80 times 1 is 80, and over 16. And then that would be 80 divided by 16. It's going to give us 5. And then we would have been left with, the ounces would have canceled ounces, leaving us with LBS. So 80 ounces is equal to 5 pounds. So the incorrect step here was using the wrong conversion factor. Remember that whenever you create conversion factors, you can always come up with 2 of them, and you just need to determine which one will be the correct one. And if you're trying to get whatever the measurement is you're trying to get to, you want it in the numerator, because the one in the denominator is going to cancel, like you see here, yards canceling yards. All right, so this one was lengthy, but it is complete. So that was lesson 2.1 from the text, where we did properties and operations.